What would you say if I told you that a frozen galaxy has been wandering around the cosmos for billions of years as a living fossil? The James Webb Telescope has now found such a fossilized galaxy, which hasn't produced new stars in billions of years, but is still there. In astronomy, fossil galaxies are thought to be remnants from the early days of the universe and give our scientists fascinating insight into the developmental history of galaxies and into the developments in the early universe. Typically, these fascinating fossil galaxies are found at the center of huge galaxy clusters. They may have been left over from merging galaxy clusters, but these odd galaxies raise questions about why some galaxies freeze and virtually stop growing very early after their formation and why these galaxies are still active in their own right. The James Webb Project should finally give us important insights into the early history of the universe. Since the telescope's launch, we have been surprised repeatedly. The telescope is showing us scientific wonders by the dozen, and the list of cosmic curiosities is growing longer and longer. We still don't know why and how galaxies formed, and we know very little about why. These galaxies have hardly changed in shape and composition since the early days of the universe, making them witnesses to an APO about which we know very little thus far. Research is currently concentrating on very old and distant galaxies that date back to the early days of the universe in order to finally understand the true evolution of matter. The fossil galaxy that the James Webb Telescope has discovered is another exceptional example in the list of discoveries. Galaxies have been clustering together more and more as the universe has evolved. Astronomers and cosmologists refer to this explosion of star formation as a starburst because it occurred so quickly and produced billions of stars in the shape of a perfect elliptical spiral. The galaxy formed incredibly early, extremely well, and widely for evolutionary steps that take billions of years for other galaxies. After that, the galaxy's star formation essentially stopped, and it hasn't changed much since. It is regarded as a scientific miracle that these stunning galaxies can survive despite the stagnation in star formation. It is most likely caused by the distribution of gases and the influence of dark matter and dark energy. It is, undoubtedly, unusual for a galaxy to become a fossil so early in the universe's evolution, but scientists still don't fully understand how dark matter and dark energy affect the formation of visible matter and galaxies. The Perseus Galaxy Cluster's galaxy fossil NGC 1277. Isn't it amazing that tools like the James Webb Space Telescope's special infrared spectrometers will allow us to examine things that are millions or even billions of light-years distant from us? For the first time, scientists can now see through clouds of cosmic dust owing to the James Webb Space Telescope, which can detect light at wavelengths that are invisible to the human eye. The telescope gathers the smallest remnants of light and transforms them into images that humans can see. In the end, dust and gases make up all matter and all galaxies in the universe, and cosmic dust is a regular occurrence. Since infrared light can pass through dust clouds and turn these light trails into images, we are now able to see parts of the universe that Hubble's eyes were unable to see. The dust in space can be so dense that telescopes like Hubble frequently malfunction due to impenetrable walls of dust. Despite its shortcomings, Hubble was already a significant space research tool, and it was able to find the galaxy NGC 1277, which is located around 220 million light-years from Earth. The stars in NGC 1277 are all very old. Image a galaxy with virtually only ancient stars. This galaxy is another live remnant from the early epochs of the cosmos. A blend of shape, beauty, and utility that hasn't been significantly improved upon in billions of years. The great majority of the stars in this galaxy are between 10 and 12 billion years old, and as of right now, they are still very much alive. In contrast, our Sun most likely has a lifetime of only 9 billion years. It's odd that so many incredibly long-lived stars have formed in this galaxy. The starburst theory is currently the most widely accepted explanation for the unusually old and well-developed galaxies that Webb discovered. Explosive developments could be the reason why, in contrast to fossil galaxies, thousands of beautiful and highly advanced galaxies were already present in the cosmos 200 or 300 million years after the Big Bang. Galaxies have undergone development. Since the early days of the universe, when stars were born, perished, migrated, and merged with others, repeatedly changing their appearance and shape, the galaxy is almost entirely made up of old metal-poor stars, which were common in the early universe until recently. However, scientists believed that these old stars from the first populations did not have a particularly long lifespan in the galaxy. In contrast, NGC 1277 has not formed any new stars in billions of years. On the other hand, NGC 1277 appears to be very stable and to have reached an almost unbelievable age. It is possible that some mechanism that has not yet been identified has frozen the processes within the galaxy. Knowing the precise nature of this mechanism would be crucial to our understanding. A force that first explodes entire galaxies into growth and then freezes them and permits them to persist in their once acquired form could interestingly indicate a previously unknown magnitude in the universe. The extraordinarily big black hole at the center of NGC 1277 accounts for around 14% of the galaxy's total mass. There are additional oddities around this black hole, and the mass fraction is already abnormally large. Normally, over billions of years, this black hole would have to consume a significant portion of the galaxy's matter. As a result, the galaxy would shrink, especially if it did not form new stars. It is currently unknown whether the black hole's mechanisms in this galaxy have somehow stopped. Have you ever heard of an Einstein ring? These astronomical objects were long a purely hypothetical assumption. Essentially, the mathematical genius Albert Einstein predicted their existence, but no one has seen one for nearly a century. Unlike other fossil galaxies, NGC 1277 is also not located at the center of a massive galaxy cluster. This galaxy is largely isolated in a region of the universe where there are very few galaxies. Simply stated, Einstein rings are exceptional instances of gravitational lensing. Nevertheless, they produce a perfect ring rather than an arc like a magnifying glass. One of these objects, identified as SDSS J12, 26 plus 2149, has just been found in a galaxy by the James Webb Space Telescope. The discovery of the Einstein ring around SDSSJ1 12.6 plus 2149 in the depths of space was made possible by the distortion of the light emitted by the galaxy, and only James Webb's fine sensors were able to pick up the faint emissions from this physical wonder. It's another of those rare cases in science, and we can thank the new telescope for its extraordinary capabilities. In this instance, the stretching is not only an exciting physical effect but also significantly magnifies objects behind it. As a result, an Einstein ring has an effect similar to that of a gravitational lens, both of which enable researchers to see objects that are extremely far away and nearly invisible to our eyes without these effects. An intervening galaxy cluster has stretched and distorted the light through its mass in such a way that it is stretched in a ring shape. The galaxy cluster AEL 370 is where the first Einstein ring was ever observed. Astronomers were able to study the far-off galaxy in great detail and learn about its structure and star formation rate thanks to this cluster, which even provides one of the most amazing views of a full Einstein ring ever seen. The Einstein ring around AEL 370 is another excellent illustration of how the general theory of relativity works, beyond this completely fanciful element. Works in practice and continues to enable new astronomical discoveries thanks to the gravitational lensing effect. The galaxy GNZ11 is one of the oldest and most distant G galaxies ever discovered. It is located approximately 13 billion light-years away and dates back to a time only 400 million years after the Big Bang. The lens effect amplified the light from this galaxy, giving astronomers important insights into its composition and structure. The Hubble Space Telescope, made this discovery at a time when scientists believed the telescope had long since reached the limits of its capabilities. Max J1749 plus 22223 Lens star 1. The most distant individual star ever seen was also discovered by gravitational lensing. The star is located in a galaxy about 9 billion light-years away without the gravitational lensing effect caused by a cluster of galaxies between the star and Earth. The light from this star would be far too weak to be detected at all. The gravitational lens amplified the light by about 1,000 times, enabling astronomers to study a single star at such a great distance in detail. For the first time, individual stars from distant APO are a special treat for scientists. Now, with the help of the James Webb Space Telescope, we can break down light signals like those from Max J1149 plus 2223 Lens star 1 into their components, and scientists can quickly obtain perfect analyses of the elements and gases that made up the stars of the early universe. Subscribe to the channel. Now, we are constantly publishing exciting videos about space exploration and the latest findings in astronomy. And